Introduction of U substitution. We need methods for evaluating more complicated antiderivative integral. So how does this U substitution work? U substitution essentially reverses the chain rule for derivative. In other words, it helps us integrate composite function. For example, this is derivative using chain rule. Okay, ddx sine of x squared equal to cos x squared multiplied 2x. So what if we integrate it, or we can call it antiderivative? Okay, so integrate of cos x squared to the multiplied by 2x dx equal back to the, it is same as this. So sine equal to sine x squared plus c. So this is chain rule for derivative, and this is for U substitution. Half from integrate of this, okay, integrate of this equal to this. Yes, it is same. Okay, so it operates like this. So first we let gx equal to u, and then f prime u equal f prime u, and then it becomes like this because we can just straight away substitute u into the gx. So it becomes f prime u. And then for this side, how about this side? This side we differentiate it. Okay, so we differentiate the gx is u, and then we get du dx, and then g prime x is du dx. We have to get like this, the formation of this, so we multiply both sides by dx. Here we can cancel it, and we rewrite it again, and we got g prime x dx equal to u. So we substitute all the f prime u here and du. We get it, integrate of f prime u du, and then we get again fu plus c. So that's how f prime equal to f of g of x plus c. We get it again like this. Yes. Okay, that's all for the introduction.
In this video, I'm going to show you how to integrate using U substitution. So, if you have this kind of question, what you have to do? So, to solve this, first, we need to find what is U variable. So, for this question, U is equal to x squared plus 5. From this, since U is equal to x squared plus 5, so du is equal to 2x dx. Next, if you divide both sides with 2x, we will get dx equal to du over 2x. After that, we will replace x squared plus 5 with u and dx with du over 2x. So, we get 2x u to the power of 3 du over 2x. Here, we can cancel 2x, and what we have left is u to the power of 3 du. So, antiderivatives of u to the power of 3 du is equal to 1 over 4 u to the power of 4 plus c. And the last thing we need to do is replace u with x squared plus 5, and the final answer will be 1 over 4 x squared plus 5 to the power of 4 plus c. Next, let's try to answer integration if we have sine cos tangent question. So, here we have the question. First thing we need to do, just like previous question, we have to find u variable. So, u equal to 4x. Since u equal to 4x, so du is equal to 4 dx. Next, we have to divide 4 to both sides, and now we get du over 4 equal to dx. So now we have to replace 4x with u and dx with du over 4. And now we have 4 cos u du over 4. Here we can cancel out 4, so we will get cos u du. So antiderivatives of cos u is equal to sine u plus c. And the last thing we need to do is replace u with 4x, and the final answer will be sine 4x plus c. For the last one, let's try with exponential function. Here is the question. So, just like we did just now, firstly, we have to find the u variable. From this question, u is equal to x squared. Since u is equal to x squared, so du is equal to 2x dx. Next, we have to divide both sides with 2x. And now, we get du over 2x equal to dx. So now, we have to replace x squared with u and dx with du over 2x. And now, we have 2x e to the power of u du over 2x. We can cancel out 2x, and now we have e to the power of u du. So, antiderivative of e to the power of u is equal to e to the power of u plus c. So, the last thing we need to do is replace u with x squared. And the final answer will be e to the power of x to the power of 2 plus c.
Okay, so this section is about U substitution, Q and A. Okay, I will show you how to solve the question. Okay, first we got integration of 3x squared plus 2x to the exponent of x, 3x power of 3 plus x squared dx. Okay, so how are we going to solve this? If you want to try first, you can pause this video and you'll get to see the answer and the ways to do it, whether it's correct or not. Okay, so first, what do we gotta do? Okay, so first we got to let u equal to the x to the power of 3 plus x squared. So we differentiate the u. We got this. Okay. We got to multiply both sides by dx. Then we get du equal to 3x squared plus 2x dx. And compare this to the equation. Compare this equation to the original equation. So, if you want to see it more clearly, we can write this integration of 3x squared plus 2x dx and exponent of x to the power of 3 plus x squared. And then we substitute the du, and here is u, so it will become like this, and we integrate it, it will become exponent u plus c, and we will get exponent of x to the power of 3 plus x squared plus c. Okay, that is about the first question. And how about the second question? So here we got the integration of tan of x dx. Okay, how do we going to solve this? Okay, once again, you can pause it if you want to try first. And yeah, so how to solve this question? So we could say because tan x is equal to sine of x and cos of x dx, so we can get it like this. So we can also rewrite it like this, because here you could say the derivative of x is the negative sine of x. So we can rewrite it as like this. It equal to negative integration 1 over cos x to the bracket of negative sine x dx. So let u equal to cos x, and we got du dx equal to negative sine x. So we can rewrite it as du equal to negative sine x dx. As we let earlier, cos x equal to u, and we substitute it, it will become like this. So integration of 1 over u, we will get ln u. So this ln u plus c, and then we substitute back again the u, so we will get it actually negative ln cos x plus c. So here we go. This is the third question, the last question. So we got the integration of square root to the 7x plus 9 dx. Okay. Once again, you can pause this video if you want to try first. Okay, so let's move on. How to solve this question? We let u equal to 7x plus 9. Okay, and then we differentiate it, we get 7. So, how does this equation here, okay, relate to this? Okay, this is the integral of the scalar times the function, and it is equal to the scalar times the integral of the function. So we applied it here. Okay, so integration 1 over 7 times 7 to the square root 7x plus 9 dx. We bring 1 over 7 here outside, and it will rewrite it. So 1 over 7 integration of square root 7x plus 9. So earlier we differentiate the du, we got 7 dx, right? Yes, this form. Okay. So du equal to 7 dx. It's the same. So here 1 over 7 integration of square root of u du. So to easier our work, so we rewrite the square root as u 1 over 2 to the power 1 over 2. So it become like this, and then we integrate it. Okay, 1 over 7, okay, 2 over 3 u to the power of 3 over 2 plus c, and we multiply here, multiply the scalar here, so we will get 2 over 21 u to the power of 3 over 2 plus c, and it will become like this. And that's all question of this last question.
After learning all those just now, maybe you are thinking, is there any function we are learning this? So, basically, U substitution essentially reverses the chain rule for derivatives. In other words, it helps us integrate composite functions. So, in daily life, U substitution function as: number 1, an architect engineer uses integration in determining the amount of the necessary materials to construct curve-shaped constructions. For example, dome over a sports arena, and also to measure the weight of that structure. Number 2, in electrical engineering, integration is used to determine the exact length of power cable needed to connect two substations which are miles away from each other. And the last one is, in physics, integration is very much needed. For example, to calculate the center of mass, center of gravity, and mass moment of inertia of a sports utility vehicle.